Hello, geometry kids. How are you guys all doing? Just to let you guys know, there's no new homework tomorrow, Friday, or Monday. So you can use that time to get caught up if you're behind. If you need me to unlock something, send me an email, let me know. Or if you need help with anything, let me know. And as you may have seen, there's a new time to meet with me on Google Meets instead of like 40 minutes here, 40 minutes there, different times. We're going to meet every day from 9:30 to 10:30. So if you have any questions, you come on any day 9:30 to 10:30, any school day. So if you have any questions today, 9:30 to 10:30, come on and let me know. If that doesn't work, you can always send me an email. All right, so happy Thursday, kind of like happy Friday, being there's no new homework Friday, Monday, but definitely use that time to get caught up in your classes, check your grades, make sure you have everything done. All right, so we just finished our last chapter. Now we are starting chapter 11. It's on area, surface area, and volume. So we're going to start with 11.2. 11.1 is basic area. You guys already know or should know, like area of a parallelogram, base times height, stuff like that. So 11.2, area of a regular polygon. All right, so it says the regular polygon. Now remember, area is like length times width. Right, it's like the carpeting or the flooring. How much is on the inside? It's not the perimeter, it's not the fence. How much grass is on the inside? All right, so it says a regular pentagon has a side of approximately 6.5 yards. Now, what does that word regular mean? That means the word regular means that all the sides and all the angles are the same. So that word regular is super important. And all the polygons we're going to do is going to be regular. So that's will make it easier. But that means all of the angles and all of the sides are the same. All right, so if we know that one side is 6.5, then actually we know that they're all 6.5. So this is going to be 6.5, this is going to be 6.5, this is going to be 6.5, and that's going to be 6.5. So they're all going to be 6.5. The apothem. The apothem is an interesting word. The apothem goes from the center, where I just marked that little tiny purple dot, down to a side perpendicular. All right, so if we're trying to figure out, okay, so what is the area of this pentagon, what I like to do is I like to divide it up into triangles. And if you look, that actually splits into two triangles there, but if you look at this being one blue triangle, there's another blue triangle, there's another blue triangle, there's another blue triangle. I look at this as 5 triangles. And then if I can just find the area of one triangle, then I can find the area of all of the triangle. All right, so how do you find the area of a triangle? So the area of a triangle, is simply 1/2 times the base times the height. Well, this is pretty easy because you already know the base and the height. The base of this blue triangle is simply 6.5 times 4.5. So the area of the triangle is 1/2 times 6.5 times 4.5. That is the area of the triangle. So then to find the area of the entire pentagon, well, if you look, there are, I can number these, I don't know, let's use kind of out of color here. You can use red. There's 1, 2, 3, 4, 5 triangles. Why are there 5 triangles? Because it's a pentagon. So there's 5 sides. So if we count each side, there's 5 triangles. So the area of the pentagon is equal to 5 times the area of the triangle. And that is going to be, you can put that right in your calculator. So you can go 5 times 0.5 times 6.5 times, oh my goodness, times 4.5. And that is going to give us 5 times 1/2 times 6.5 times 4.5 is 70, oops, I need something to write with, is 73.125. And it's got to be yards squared, because area is always squared. It's two-dimensional. The length of the fence is feet or yards or miles, because it's one-dimensional. The area is two-dimensional, so it's yards squared. It's base times height. And then you have the volume, which is three-dimensional, so that's going to be yards cubed. We'll get into that next. Okay, for the next problem, same thing, except for instead of giving us the side of the pentagon, they just tell us what the perimeter of the entire pentagon is. So if we know the perimeter of the entire pentagon, we can still find the area of the polygon. We know it's an octagon, that's 8. So if I take 24 and I divide it by 8, I know that each side is 3. So if I know that each side is 3, I can just label each of those as 3. I don't even need to label them all. All I need is just this bottom one. So then I can simply make this into a triangle. Sorry, the pen I got never worked, so I'm just using my fingers still, best I can. All right, so if we look at that, we can find the area of that one triangle. So the area of that triangle is going to be 1/2 times 3 times 3.6. Okay, so how many triangles do I have in here? Well, it's an octagon. I'm going to have 8. So now I can say, okay, well, the area of the octagon is going to be 8 times the area of that triangle. So then in my calculator, I can simply do 8 times 0.5 times 3 times 3.6. And I get an answer of 43.2, and that is yards squared. Okay. All right. Now, they might give you on Alex a different equation to use. They might give you the area is equal to 1/2 times the apothem times the perimeter. And that is actually the same thing as we have. So the apothem here is, oops, I'll get out my pointer. The apothem here is 3.6. This is 3.6. This is 3.6. And then it's 1/2 of the perimeter. Well, the perimeter is 24. Here I have the 8 times the 3, which is 24 times the 1/2. So if you want to use 1/2 times the apothem times the perimeter, you could also use that formula. So that would be the area would be equal to 1/2 times the apothem, which is 3.6, times the perimeter, which is 24. And if you do that on your calculator and take 0.5 times 3.6 times 24, you will find out that you get the exact same area. You still get 43.2 yards squared. All right, okay, moving on. All right, now these get a little bit more difficult because we don't have the height of the triangle. So this is a triangle. We just do 1/2 times the base times the height, but we don't have the height of the triangle. We have the radius of the triangle. Okay, that dot from the center out is called the radius of the triangle. So how are we going to figure out like that? Okay, so we're still going to divide the triangle up into 3 triangles. So we're going to still do the same thing we did last time. We are going to divide this here and divide that there and divide that there. Okay, so now we still have 3 triangles, 1, 2, 3 triangles. Now there's a couple different ways to do this. So with this being 6 and this over here being 6 and this over here being 6, we have all the radii. And now what we need to do is we need to say, okay, well, I actually need to figure out the area of that blue triangle. So I need the base, which is the apothem, and I need the height. So how am I going to figure out the base and the height? So I'm going to redraw that little blue triangle, this one right here. where this is 6. And then I'm going to draw the base, or I'm sorry, the apothem, and there's my base. Okay, so if I look at that, I'm just going to look at this red triangle right here. When I look at that red triangle, I can actually figure out a few things here. So I know that on the inside here, this right here is 360 degrees. So if that's split up into 3 triangles on the inside, all of those are 120 degrees, which makes each of those 60 degrees. So this right here is 60 degrees, as is that right there. So if those are 60 degrees, this is obviously a 90. So then that is going to be 30 degrees. So guess what I have? That's why it's called special right triangles. I have a 30, 60, 90. So I'm going to set up my 30, 60, 90. And I'm going to say, okay, well, what is across from the 30-degree angle? Well, across from the 30-degree angle is my apothem. Okay. Across from my 60-degree angle is the base of the red triangle. So I'm going to put a B there for the base of the red triangle. I'm going to put it in red. And then across from the 90-degree angle is 6. So can I figure out the base and the height of that red triangle? I sure can, because in the 30, 60, 90, I have 1, √3, and 2 that we learned before. So I set that equal. And now I can cross multiply and figure out the base. So the base, 2 times the base, is going to be 6 times the square root of 3. All right. And I actually can leave it right there, because if that's the base, isn't this also the base? And the base plus base is 2 base. So the base of the blue triangle is 6 √3. All right, now I want to find the height of that triangle, the apothem. So that's my A for apothem. So now I can cross multiply there. So then I'm going to get 2A is equal to 6. So if I cross multiply to get 2A is equal to 6, then my apothem is 3. All right, so how do I put all this together? I'm trying to find the area of this blue triangle here. Okay, so what is the area of that blue triangle? The area of the blue triangle is going to be equal to 1/2 times the base, which we just figured out is 6 √3, times the height, which is 3. All right, so then to find the area of the big triangle, so I'm going to put that in green. So to find the area of the green triangle, the big one, well, there's 3 triangles inside there. So it's going to be 3 times 1/2 times 6 √3 times 3. And it says to leave it in simplified radical form. If it didn't say to leave it in simplified radical form, I would simply just go 1/2 times 6 times 6 times the sine of 120 degrees, which is the triangle we learned last chapter. All right, so then it says leave it in simplified radical form. So we take 3 times 6 times 3, which is 54, divided by 2, which is 27. That's going to be 27 times the square root of 3. And my answer is going to be in meters squared. Meters squared. So that was not easy. But you guys can go back and look at that video if you have, and find me on Google Meets if you have questions. Okay, the last one. Okay, so this one, we're going to have to hurry, we only have a minute. So this one I'm going to make into a triangle as well. So this middle angle is going to be 360 divided by 6. That's 60 degrees. So if that is 60 degrees, that's actually an equilateral triangle. So that means that all of the sides are 60 degrees. So that works out really well, because if all of the sides are 60 degrees, 60, 60, 60, that means it's equilateral, so all of the sides are the same. So that means that this, if that's 4, this is also 4, and this is 4. All right, so then we can find this triangle here. Now we just need to find the height of that red triangle. So if this is 2 and this is 4, how can we find the height of that red triangle? You can use a 30, 60, 90, or you can use a squared plus b